Lesson 5 Day 3. This is a really tricky lesson, so we're spending 3 days on it to really, hopefully, help you be successful with figuring out how to work with compound inequalities. What you see is you see a little grid with the words and or to represent our compound inequalities, and then I'm going to draw some graphs over on the left, and I'm going to explain what type of graph will be created if the two inequalities were separated by the word and, or if they were separated by the word or. So my first inequality example, I'm just going to draw two rays. So if my first ray was starting on 1, and it was x is greater than 1, and my second one, we'll say is x is less than or equal to 3. What happens if you look at those two rays and they're combined by the word and? What would your solution look like? Well, the word and is an intersection, so I'm looking for what they have in common or for where they overlap. So intersect or overlap. I notice that my two graphs overlap starting at the 1 but ending at the 3, so they overlap in an interval from 1 to 3. So this is an interval graph that is formed, and I can name my interval 1 is less than x, which is less than or equal to 3. All right, now let's say that those same two inequalities were separated by the word or. The word or is not an intersection.
Garrett Cummings, please report to the office. Garrett Cummings, report to the office.
So I just need to unite together my two number lines. So if I unite them together, here's what I'm talking about. If I take this ray and I unite it with the other one, it covers the whole number line. So this union is going to give me the entire number line. So not just from 1 to 3, the entire number line. So it's all real numbers. The entire number line is covered. So my solution is the entire number line. My second example, I'll stick with my 1, 2, and 3 again. My first ray, I'm going to go with a closed circle on the 2, and we'll go to the right. My second ray, I'm going to go with an open circle on the 1, and also go to the right. Now, if the word separating my inequality is and, I'm looking for where these rays overlap with each other, what they share. So if I slide them, I can see that what they share is going to be from 2 and higher. It's going to be from 2 and higher. So, separated by the word and, numbers that are greater than or equal to 2 and greater than 1, well, they are really just greater than or equal to my 2. So my solution ray with the word and, my solution ray starts at the 2. So x is greater than or equal to 2. That's where they overlap each other. Now my union, if I switch the word to or, my union is going to look a little bit different, because my union, when I combine them or unite them together, is going to start at the 1 instead of the 2. Because the points or the numbers, they don't have to be on both of those rays, they just have to be on one or the other. So x is greater than 1. So both of these we called one ray, one ray. So we had an interval, all real numbers, and these are both called one ray because they are one ray. It's just that they're not the same ray as each other. Okay, my last example, I go with my 1, 2, and 3. And I am going to need to have a closed circle on 1, and we're going to go to the left, and then I'm going to go with an open circle on the 3, going to the right. So if we start out with two rays pointing in opposite directions, and the word separating the inequalities is and, we're looking for where they intersect or where they overlap, and these don't. They don't intersect. They don't overlap, so we said this was called an empty set. So, empty set. They do not have anything in common. There aren't any numbers that fit both of those requirements at the same time. The union, however, because you don't have to fit both of the requirements, just one or the other, the union is going to include both of them. So the union has two rays, and they're just going in opposite directions. They don't share anything. They don't have to. So two rays. So this is just a recap of the three different types of and inequalities and the three different types of or compound inequalities. So there are 6 different things that we worked on in this section. Okay, now we have just 2 problems that we're going to solve. If I subtract 1, then divide by 5, I get x is greater than or equal to 1. The second inequality, I add 7 and divide by 3. So x is less than or equal to 4. So my number lines just need to go from 1 to 4. Greater than or equal to 1, and less than or equal to 4. If a number has to fit both of the requirements, because we've got the word and as our connecting word for our compound inequality, I'm looking for where they overlap. So they overlap starting at the 1, ending at the 4. So it's an interval from 1 to 4. Both of my circles are closed, so both of my symbols are less than or equal to. So 1 is less than or equal to x, which is less than or equal to 4. My second one, you may notice that these numbers are looking pretty similar by now since we've solved these same inequalities over and over. So all that we're doing is changing the connecting word. Okay, so less than or equal to 1. It's close to the left. Greater than or equal to 4 is closed going to the right. So, with the connecting word of or, if your numbers just have to be on one or the other, if you unite together these 2 number lines, you're going to keep both of them. And we have 2 rays as a result. So numbers that are less than or equal to 1 or greater than or equal to 4, we're not looking for where they overlap, we're just looking to unite them together, combine them. Now you should be able to do your review homework. It's on page 826. Make sure that you are in section 5.4. And 1 through 8, 10 to 13 are the problems that we would like you to do for extra practice. These problems combine together the and the or inequalities. So you've just got to be careful and make sure you understand which one is which?